Hi children, good morning. Good morning all of you. Welcome to St. Clair's from the online class children. Right? Regarding 10th class, recently we are conducting one of the exam children. I hope that you are already written very well I think. Right? Already you got good marks. So some of the few members they got less marks also. Right children? So whatever it may be, in this academic year, you have to focus on your 10th class and you have to more concentration you should pay on your 10th class, right children? Okay, see here regarding 10th class we are already finished that one of the lesson, that is the acids, bases and salts, and the second lesson atomic structure. Now we are going, it's going on now, there is a periodic classification, right children? So regarding periodic classification of the elements also we are finished half of the syllabus, right children? So regarding periodic classification of the elements we are finished about double triads law and Newton's octaves law and Mendeleev's classification of the elements and modern periodic table, right children? So regarding modern periodic table we discussed a lot of points children. So I will give some information in the form of tabular forms, right children? So what I am giving the tabular forms, you should write each and everything in your CW, right children? CW or running notebook, right children? So each and everything you have to follow that because of it's very important for you, right children? So now I will give the some tabular forms, right children? So in the modern periodic table, so we have to observe that there are 8 groups are there. How many groups children? There are 18 groups. There are 18 groups and 7 periods, right children? In 18 groups we have 8 A groups, that means first A, second A, third A, fourth A, fifth A, sixth A, seventh A, eighth A group elements, right children? So these are the main groups we have to consider here. See here, first A group, that means it is represented as a Roman numbers. What children? Roman numbers. So what we have the Roman numbers children? Here we have to consider that first A group elements, first A, and like second A, and third A, and fourth A, and fifth A, and sixth A. Like that we have seventh A and eighth A group, right children? So like here we have how many groups children? We have totally 8 groups are there. That means first A, second A, third A, fourth A, fifth A, sixth A, seventh A, eighth A group elements, right children? So these are the groups we are given some common names. We are given some common names, right children? So that is now I am giving in the form of tabular form. Please all of you write on your CW, right children? See here in the periodic classification of the elements. Now we are discussing what is the concept children. So regarding modern periodic table, what we have here, group number, group, and what is the common name? What is the common name of the group, right children? See here, suppose if we can take that first A group we have to consider as a alkali metals. What children? Alkali metals. And second A group we have to consider as a alkaline earth metals. And third A group we have to consider as a boron family. What children? We have to consider as a boron family. And fourth A group we have to consider as a carbon family. What children? Carbon family. And here fifth A group we have to consider as a nitrogen family or nictogen family. What should the nicto means? Nicto means poison. Then here sixth A group elements we have to consider as a chalcogens. What should I? Chalcogens. Then here seventh A group elements we have to consider as a halogens. What children? Halogens. And here 8A group elements we have to consider as aerosols or zero group elements or inert gases or noble gases. These are all are another names for the common names for the first A to 8A group elements. And now see children, what we have the first A group elements children? We have first A group elements hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Here except the hydrogen remaining all we consider as alkali metals. Then here alkali earth metals. What we have the alkali earth metals children? Here beryllium, magnesium, calcium, strontium, barium and radium. Right children? And here boron family. Boron, aluminium, gallium, indium, thallium. And here carbon family. Carbon, silicon, germanium, tin and lead. Right children? So Sn means stannum. That is the Latin name. So common name we have to consider as a tin. Right children? And here nitrogen, phosphorus, arsenic, strontium and bismuth. And here chalcogens, oxygen, sulfur, selenium, tellurium, polonium. Right children? And here halogens, fluorine, chlorine, bromine, iodine and astatine. And here aerogens. What are the aerogens are noble gases children? Helium, neon, argon, krypton, xenon and radon. Right children? So this is one of the table form. Please all of you write in your CW. Okay children? See here, right? Group and common name and elements. Right children? So these are all. This is the information about groups. You have to write in your CW. Right children? So group number along with the common names. Okay children? So now coming to the one more tabular form regarding modern periodic table. See here what we have that now about periods. See children, about periods. See here we have totally 7 periods we have children. How many periods? Totally 7 periods. Right children? So here period. Right children? And here number of elements. And after that we should write common name. See children, here we have totally 7 periods. Now coming to the first period. Right children? First period consists of only 2 elements. What are those 2 elements? Hydrogen and helium. Okay children? Then after, what is the common name for the first period means? It is we have to consider as a shortest period. What children? It is we have to consider as a shortest period. And here now second period consists of 8 elements. And third period also consists of 8 elements. That means second and third periods consist of how many elements children? 8 and 8 elements. And here second period it is starting with lithium, ending with neon. So this is the starting element, it is the ending element. Right children? And here third period is starting with sodium, ending with argon. Right children? So these two consist of same number of elements like 8 and 8. That's why these two we have to consider as a short periods. What children? Short periods. Okay, then here now coming to the fourth period. Fourth period consists of 18 elements. How many elements, children? 18 elements. Here starting element is potassium. Then here ending element. So helium organ, after that krypton. Right, children? So starting element is potassium, ending element is krypton. Total how many elements we have, children, in the fourth period? 18 elements. Then here fifth period. Fifth period also consists of 18 elements. Here starting element potassium, after radium. Then here ending with xenon. Right, children? So these two periods consist of total of how many elements we have, children? So total we have 18 and 18. That's why we have to consider the long periods. What, children? Long periods. And here sixth period. Sixth period consists of totally 32 elements, children. So it is starting with cesium, ending with radon. Ending with radon. So totally 32 elements are there in the sixth period. That's why it is we have to consider as the longest period. What, children? Longest period. And after that, seventh period. Seventh period totally now. So in some books they are given incomplete period. Whatever it may be, we have written in the 31 elements with starting with francium, so ending with unoctium. Unoctium. Some till today we know some elements, we don't know some elements. That's why here seventh period we have to consider the incomplete period according to our textbook. Incomplete period. Right, children? So these are the common names for the first period to second period, third period, fourth period, fifth period, sixth period, and seventh. Right, children? So this is the information about periods. Right, children? See here, first period, shortest period with 2 elements. Second period, second and third period, short periods. Third and fourth and fifth period considers the long periods. Sixth period is the longest period. Seventh period is the incomplete period. So right, children? So now coming to the, we have some blocks we have, children. What do we have the blocks? S block, P block, D block, F block. Right, children? See here. Here about blocks. First one about groups, second one about periods, third one about blocks. Right, children? See here S block. S and P. S and P we have to consider as a representative elements. Representative elements. See here, except noble gases. Except noble gases. Right, children? And after that, D block elements. D block elements we have to consider as a transitional elements. What, children? Transitional elements. Okay? And here the F block elements. F block elements we have to consider as a inner transitional elements. Inner transitional elements. Okay, children? And here F block elements. F block elements again consider as a 2 blocks. What are those 2 blocks? Lanthanides and actinides. Lanthanides and actinides. Here lanthanides again we have to consider as a rare earth metals. What, children? Rare earth metals. And here actinides we have to consider as a radioactive elements. What, children? Radioactive elements. Okay, children? See here, transition elements about D block elements. F block elements are considered in the transition elements. Again, in the transition elements considered as 2 blocks, lanthanides and actinides. Another name for lanthanides is rare earth metals. Another name for actinides is radioactive elements. Right, children? So this is about blocks. Okay, children? So now coming to the we have first year group, second year, third year, fourth year, fifth year, sixth year, seventh year, eighth year group elements, children. So what about general electronic configuration? What about general electronic configuration? Right children? See here about general electronic configuration and its group number and its valence electrons, its valence oxidations. We will discuss these all points. Right children? See here, suppose if you can take that about first A group element. So see here, first we have to consider the group. So what is the group here? Suppose if we can take the first A group. First A group. So first A group, the general electronic configuration for first A group elements is NS1. General electronic configuration. General electronic configuration of first A group is NS1. Then for the second A group elements, here second A group we have to consider as a NS2. NS2. And third A group. Third A group, that is NS2 NP1. NS2 NP1. Then here fourth A group. Fourth A group NS2 NP2. And fifth A group. Fifth A group NS2 NP3. And sixth A group. Sixth A group we have to consider as a NS2 NP4. And here seventh A group. Seventh A group NS2 NP5. And here eighth A group. Eighth A group we have to consider as a NS2 NP6. These are the general electronic configurations for first A to 8th A group elements. Now coming to the number of valency electrons. Valency electrons. First A group consists of 1 valence electron. Second A group consists of 2 valency electrons. Third A group consists of 3 valence electrons. Fourth A group consists of 4 valence electrons. Fifth A group consists of 5 valence electrons. Sixth A group consists of 6 valence electrons. Seventh A group consists of 7 valence electrons. Eighth A group consists of 8 valency electrons. Right children? Here, see here, first A group 1, second A group 2, third A group 2 plus 1 3, fourth A group 2 plus 2 4, fifth A group 2 plus 3 5, sixth A group 2 plus 4 6, seventh A group 2 plus 5 7, so eighth A group 2 plus 6 8. Right children? Now coming to the valency. See here, what about valency? Here first A group elements valency is always 1. Second group elements valency is 2. Third A group valency is 3. What about fourth A group elements valency is 4. But what about fifth A group children? Fifth A group, so 8 minus 5. 8 minus 5 means 3. Sixth A group, 8 minus 6 2. And here seventh A group, 8 minus 7 1. Eighth A group elements valency is 8 minus 8 to 0. Here 8 minus 4. Here it is 8 minus 5. Here it is 8 minus 6. Here it is 8 minus 7. Here it is 8 minus 8. Right children? So this is about valences of 4th A group, 5th A group, 6th A, 7th A, 8th A group elements. Because of here, so like carbon, silicon, these we have to consider as non-metals. And 5th A group, hydrogen, phosphorus, we have to consider non-metals. And in 6th A group, we have to consider as oxygen, sulfur, selenium, tellurium. And here 7th A group, fluorine, chlorine, bromine, iodine, these are all having valency 1. And here 8th A group valency is 0. Right children? So this is about valency of first A to 8th A group elements. Then now come to the oxidation state. What children? Oxidation state or oxidation number. So about oxidation state, all the first A group elements exhibit the oxidation state is always plus 1 children. Then here second A group elements plus 2. Third A group elements plus 3. Here fourth A group elements, some elements have exhibited the plus 4 to minus 4. Especially in organic compounds, it can exhibit the plus 4 to minus 4. Rarely we had to consider as a minus 4. And here 5th A group elements oxidation state is minus 3. 6th A group elements oxidation state is minus 2. 7th A group elements oxidation state is minus 1. 8th A group elements oxidation state is 0. So from here onwards, number of valence electrons minus 8. That means group number minus 8. That means 8 4 minus 8. 4 minus 8 means minus 4. Here 5 minus 8 minus 3. 5 minus 6 minus 8 minus 2. 7 minus 8 minus 1. 8 minus 8 is 0. So this is about what is the general electronic configuration, number of valency electrons and its valency and oxidation states. Right children? So this is the one of the tabular form regarding modern periodic table. Right children? So please each and every one you have to write in your serial. Right children? So this is about first A group element, second A group element, first A to 8th A group element is general electronic configuration and number of valence electrons and its valency and its oxidation state. Right children? So now coming to the what about general electronic configurations for S block elements, P block elements, D block elements and F block elements. Right children? So here general electronic configuration for S block elements. Here